Hi, and welcome to Mathclass Heroes. I'm Gabriel, and today I'm gonna be talking about functions, but not just any type of functions. I'm here to tell you about bijective functions. Now, before we start, let us recall what a function is. Remember that a function is a way of assigning a number to another number or an object to another object with the particularity that every element that we have can only be assigned to a single element. For example, if we take all the people in the world and to each one we assign his or her age, then this will be a function because at a specific time a person cannot be 5 and 10 years old. Now, for a function to be a bijective function, it has to satisfy two conditions. First, it has to be an injective function, also known as a one-to-one function, and secondly, it has to be a surjective function, also known as an onto function. A function is going to be an injective function if every two different elements cannot be assigned to the same element. For example, the function that assigns to each person his or her age is not going to be an injective function because we could find two different people with the same age. But if instead of considering all the people in the world, we consider only the people within a certain country, and instead of assigning their ages, we assign their identification number, then this will be an injective function because in that particular country we will not be able to find two different people with the same identification number. Similarly, if we consider the cars within a certain country and to each car we assign its number plate, then this will be an injective function because in that country we will not be able to find two different cars with the same number plate. Now, when trying to see if a function is an injective function, we shouldn't lose sight of its domain. For example, the function that assigns to each person his or her age is not injective when it is considered over all the people in the world. But if we consider this function only over a family, mom, dad, and two kids, all with different ages, then this function will be injective because we will not be able to find two members of that family with the same age. Another example, the function x squared, is not going to be injective when we consider its domain to be all the real numbers. For example, minus 1 squared equals 1 squared equals 1, and of course 1 and minus 1 are different numbers. But if we consider this same function only over the positive real numbers, then it actually will be an injective function. Graphically, a function is going to be injective if every time we draw a horizontal line over the graph, that line crosses the graph at most once. It can cross it once or not cross it at all. To check if a function is a surjective function, well, it's a little bit harder. A function is going to be surjective if it can reach every element of its codomain. And what do I mean? For example, the function that assigns to each person his or her age, if we consider the codomain to be all the natural numbers, then it's not going to be surjective because it can never equal 1000. We will never be able to find a person being 1000 years old. On the other hand, if instead of assigning their ages, we assign the last number of their identification numbers and consider the codomain to be the numbers 0, 1, 2 to 9, then this is going to be a surjective function because no matter if we take the number 5, 7 or 9, we will always be able to find a person whose identification number ends with 5, 7, 9 or any other number considered. Graphically, a function is going to be surjective if every time we draw a horizontal line over the graph, that line always crosses the graph. It can cross it once, twice, or an infinite number of times, but at least once. For example, the function x squared, if we consider the codomain to be all the real numbers, then this is not going to be a surjective function. We could simply draw the line -1, and that line doesn't cross the graph. In fact, we will never be able to find a real number x such that x squared equals -1. The injective functions satisfy that every time we draw a horizontal line over the graph, that line crosses the graph at most once, and the surjective at least once. Since the bijective functions satisfy both conditions, then every time we draw a horizontal line over the graph of a bijective function, that line will cross the graph exactly once. So that's it. Those are the bijective functions. It's not easy to check if a function is bijective. There is a property that states that every bijective function has an inverse function, and that every function that has an inverse function is bijective, but in the end, it's not an easy task. If you have a function and need to see if it's bijective, surjective, or injective, you can write to us at the email in the description below. If you want us to go deeper into this subject or explain any other, please comment. If you liked our video, give us a thumbs up, subscribe. You can follow us on Instagram or Facebook. I'm Gabriel. This is Math Class Heroes. See you next time.